Well, hi and welcome to my shop. Thanks so much for joining me. Today my focus is going to be on the shortwave bands and finding out what's going on, because so far I don't think I've heard anything shortwave come through this radio yet, except a bit of hiss maybe on one band. But the first thing I'm going to talk about is the second schematic I received yesterday, and I've been investigating. I found another interesting variation in the schematic. Maybe variation isn't quite the right word, that may help us sort out which schematic is the one for this radio. So just to back up, I have this one. This one I'm pretty sure, this one is, it says Nostalgia Air on it. That's where I managed to get this one. And then this one was sent to me. This I think is from Pacific Radio and TV. This is part of it. Where's the other sheet? Is here somewhere. Here it is. Well, fortunately, this one comes with a nice written description of the alignment. Now, for sure, these two schematics are extremely similar, but there are differences, as I showed in the last video. There were differences all around the detector. Well, I found another one that I think is fairly critical in trying to decide which of these schematics is really the right one for this radio. Or is there a third schematic floating around out there? Maybe there is. So what I noticed is on this schematic, this is showing for the 47, this radio right on its label back here says 1567 Michigan in the United States. Supposedly this is a Canadian version of the same radio. I don't know what the story is. The rectifier for the receiver, the rectifier tube for the receiver is a 5Z5. So this radio came with a spare 5Z5. Now it turns out the 5Z5 is the rectifier that is definitely used in the amplifier. This is the separate amplifier chassis here, and there's a 5Z5 listed there. 5Z5 listed here for the receiver. So on this schematic, both the amplifier and receiver have the same rectifier tube, and it's significantly different from the more typical 5Y3, 5U4 type rectifier tubes you would find in a radio with this vintage. It's a 4-pin tube. The 5Z3 is a 4-pin tube. Do I have one handy? And maybe I don't have one handy. The 5Y3 and 5U4 are 8-pin, 9-pin, 8-pin, 7-pin tubes. They got more pins than that though. So there's no popping this into this radio. Was this what was in there originally to match this schematic? The answer is no. And I can say that because I looked carefully at the rectifier socket down here. This is riveted in, identical to all the other tube sockets. It's riveted in place. It looks exactly the same. I'm sure this is the original tube socket. So this is a 8-pin tube socket. So this must have had the 5Y3 in it. And if we look at this other schematic, the quote American schematic, and if we look, we'll see here's the amplifier 5Z3. Here's the power supply for the receiver 5Y3. So that's a significant difference here between this version and this. Maybe this is older or something, I don't know. Okay, so once again I'm back to thinking this is probably the more correct schematic. This is the one that I followed when I reinstalled missing parts. This is the one that shows the IF can has only 2 leads, or I should say a primary and a secondary, and nothing is center tapped. This one shows the center tapped IF coil here, and quite a different network just below it. So I think this is the radio I've got, but this radio shows a connection to the phono on the back. There is no such connection in this radio. So I don't know, maybe there's another schematic floating around out there, or a revision to the original schematic. So that's the confusion there. I think I can still use the alignment instructions that come on the 147. I don't think there's a problem with that. So, why don't we get started here? And best thing I can do is just turn on all my equipment, get everything warmed up and ready to go, including the radio. I'll make the connections. Actually, the connections are already made. Hey, we're almost ready to go. Let me just get everything all warmed up here.
That's the problem with our industry, and that's the problem with one pricing. Because you see, it doesn't matter how nice the salesperson was to you. People will walk away from nice salespeople all the time for a cheaper price. And, you know, sales trainers will try to convince you of the opposite all day long. But that's not the case. We have seen people walk away from a deal for $1. So,
Okay, yeah. Have you really? Okay, so that was the radio you were listening to on AM just as I left it yesterday. All working fairly well. So what I'm going to do now is I'm going to switch to the first shortwave band, and the frequency for that, you know what, I have not found a chart that shows me the frequency ranges for each band. Okay, this should help. This is the old glass dial. So look at the AM band, starting over here, it looks like 550, so it probably starts 530, 1700. That's an ordinary AM band. And we see another one down here on the outside. This is 150, 175, 300. So this is the long wave band, the one I was just trying. It goes from 150 to 4, just below the IF. Quite typical. Think about it, 150 kilocycles. That's really low. But you know, back then, 150 to looks like 354. Looks like just above 400. That's one band. Okay, the other one is of course 530 to 1700. The next band 6543. Across here, right? Well, it looks like this just dips right down into the AM band, but can't. So I'm just going to make it up. It's going to be from, let's say, 2 megahertz to 6 megahertz. And then the last one starts at 6 and goes up to 18. So 18 is not as high. A lot of these radios will go up above, well, they may not actually. This old radio this vintage may not go up too much higher, in fact. 18. And you can see how here 1 megahertz is this big, but up here 1 megahertz is just a little bit here. It's really cramming in up here. A lot of challenges tuning in stuff up here, that's for sure. But if you're going to listen in the evening, you're probably going to be listening down around here, around 6 megacycles, maybe around 9. This is the band that counts. The band we were just testing, this long wave band, there's nothing down there but noise, horrible noise. So it doesn't even really matter. So I'm going to concentrate on this band, even though we've discovered it to be dead, because it's of little interest. Let's go to the 2 to 6 band. So you got to assume they put these in order of lowest, AM, next, and highest. So next. So let me put on my headphones here. Let's see what crackly sounds you've been listening to all this time while I've been talking. So we want to get onto the correct band. It doesn't take much for me to get my head turned around. This dial's enough to do it here. So we're on AM. That's long wave. That's AM. Let me just be sure. Yep. AM. And now we're going to go to the next band. Okay. Now, we still have the signal generator set for the IF frequency. Same sort of deal. Maybe you can sneak in the radio and come out of the speaker, we can hear it. There it is. Doesn't sound any different, does it? You know, that's interesting. Let's just turn this back. Let's turn one more. See, I don't know how you can have an intermediate frequency of 455 kilohertz while you're trying to tune 150 kilohertz. Maybe you can. So there it is. So there's the IF working on AM band. First shortwave band. What about the second one? Don't hear it. Well, that's interesting. I'm sure that's saying something. So we have one band working, one shortwave band working, and that's the 2 megahertz to 6 band. Okay, let's just see if we can pick something up. Where's the tuning capacitor on this guy? It's about 2/3 closed. 2 to 6. So we'll set the signal generator here to from 2. Okay, now the signal strength is very high, even though that IF thing we just heard was very quiet. Oh, I had the volume about halfway. It could be suppressed a lot compared to this signal. This signal, I'm going to turn this down. In fact, that's a huge. That's better. That's a very strong signal. Any radio should pick it up. Didn't have to go far at all. Let's just see if it comes in at another spot. I'm suspicious. Okay, so no image coming in. At least. There we are. So in terms of signal strength and volume, again, we can't judge the volume because of the way I'm handling the sound in my shop here. But we can look at the volume control setting a little bit. That's pretty good. That's pretty good. Let's knock the signal down. Still there. Gone at that point. So that's a very low signal, and we can hear it a little bit. That's not too bad. Okay, so we can do an alignment process here, similar to what I did yesterday. By the way, I said something, I often say things that can be interpreted a little bit differently than what I intended them to say, because it's a complicated thing, and talking about it without absolute precision can open the door for misunderstanding. So I said something about these oscillator coils. All they do is retune the radio, and that can't affect its strength. Oh yes, it can. If you align these in a certain way and then fail to align this to match, it's usually the other way around in fact, then you will lose strength for sure. Even though all this has done is just change the tuning point of the radio, you will have tuned it outside the range of these coils. So yes, this just retunes the radio, but internally it will ruin the alignment if you fiddle around with these. So not without consequence all the time. That's why the first thing you do is the oscillator, which we won't do because at this point in time, without the glass dial up there, it's just not worth the effort to do it. And so what we're really doing then is we're kind of bringing these coils in to match where these ones are set, and that's kind of what's going on here, which is okay, because what we're really trying to discover is how well does this radio work anyway. And it could be knocked down by these coils. We want to get rid of the knockdown and then see what's really going on. Well, why not actually do something? Well, that's a good question. Why not do something here? First of all, I want to make sure we identify the correct coils. This handy dandy guy here is going to do it for me. So this is the diagram I was looking at here. This is the word broadcast antenna. Oh, long wave antenna. That's what that says. So we got long wave, broadcast, police, and short wave. So the police band is the one that is running from 2 to 6. You know, that makes sense. I think I think that's where the police used to be. So it's this center one, antenna. These are the two I want to do. Okay, got that sorted out. The two that are staring me in the face. Okay, we're getting nothing showing up on here. Okay, let's do a little relighting of the shop here. Man, I'm going to turn this up here, so we got a clear thing. Tune the radio in precisely. Try and get it on the meter here. There we are. I'm right near a noise source, so I'm going to go down here where it's quieter and readjust this. Okay, fighting with the AVC there a little bit. Good look at that meter. Oh, this worked really well last time. We got quite a boost. What do we get this time? Sounds like it's going down. So I backed the screw out all the way and it seemed to be going up but never actually peaking. I'm gonna just didn't do much. Let's try this one. Down, up, up, up also. Same sort of thing. Now it could be I'm doing this at the wrong end of the band. Let's put these down a little bit. So just starting to knock it down a touch. So this is as tight as I can turn these without knocking the signal off. So we'll go to the higher end of the band here. Where is that? Okay, we'll just keep going. Maybe we'll get some shortwave. Getting a little quieter up here. Okay, so this is opening the plates on that tuning capacitor. So now I'm going to raise this up to around 5, I'm going to guess. I don't think I can get there on this band. No. Down, down, down. Somewhere around here. Somewhere. Hey. What's happened? Give it more signal. There it is. Okay, tune the radio, get it right on. Okay, try these coils now. Antenna first. Sharp peak. This one here. There's a peak there. It's not very sharp. That one's almost turned out all the way. This one went in a bit. So we know from that other frequency that it knocked down that part a little bit, but I think it's okay. 5 is where you want to be anyway. You don't really care much about what's down 2, 3, 4 megahertz, but 5, you're starting to get shortwave signals. Not at this time of day though. So that's about all I can do with that band. Now what about the other two? So the low band, the one that's below AM, I'm going to forsake that for now. I'm going to go to the high end band, the next one, the last one, and see if we can't get something through on it. Something. So so that's the top band. Now remember we couldn't get 455 to sneak through, but that's not a guarantee of anything. We know we are tuned at the high end of the band now, so I'm up around 18 megahertz. So let's take it up to 18. We'll leave it here. This is quite a strong signal right now, so it should respond. heard nothing, so we'll go higher. Thought I heard something back there. Wow, not a thing. Well, I guess really signal tracing is what's called for here. The problem is I cannot trace at RF frequencies like this. My tracer is an AM radio, like broadcast band type tracer. So how am I going to determine if this signal is getting anywhere at all in the radio? I think I have a method. Okay, so what I'm going to try to do is utilize my SDR radio. That's a software defined radio. The connection is right here. And the radio itself is this little tiny can. You can barely see it here with the two inputs on it. And it's a radio receiver of a different sort. And the thing is, it's working with a computer, so I can pop it up on the screen like this. Okay, so just a quick explanation of what you're seeing here. The radio right now is tuned to 16.455 megahertz, just a random tuning. That's what this red line indicates. See, if you read the scale, you get the same thing, 16.455. So I move this red line just by clicking over, let's say, here. This number will have changed now. Now, the radio is receiving, and visually we can see all the way from 17 megahertz all the way down to below 15 here. But all we can hear is what's here. That's two different hears, by the way. So to hear it in our ear, I have to turn this on. And now what you're hearing is coming through speakers and microphone in my shop here. If I go here, let's go, and I can tune down. We can find out what that sounds like. Doesn't sound like much, does it? Okay, sound off. Just looking at the picture. Now, what I wanted to do is up around 18. Let's go a little higher here. So I just slid the whole thing over. There's a shortwave band right up here at 17.4 up to I think it's 17. I don't know, 17.9 looks like. But how can I? So we're not looking at the screen here. So this is me fooling around with the antenna to the SDR, and you can see it just kind of bopping up and down a little bit. And really what's happening here is the SDR antenna is essentially, oh, what was that wild stuff? I was looking away when that happened. What was that? Okay, I don't know what that wild stuff was, but oh, there it is again. What's going on? I got a bad clip lead. Don't give me a bad clip lead. It's again, I don't know where that came from. Yikes. Okay, so what I'm going to do is I'm going to tune the signal generator right around this frequency, 17.5, and see if you can't see a little spike show up. Okay, so just keep your eye on it for now. 17.5 is right around here. So, now, if you look on where it says shortwave broadcast, and you look where the O is in shortwave, and then you look at the waterfall display below it, you'll see a line. Now I'm going to change the frequency of the signal generator slightly, and the line moved over. That's because that is the signal generator frequency right there. So for instance, if I make that line come down to exactly 7, well, as best I can anyway, 7.5, I got it right on. And then I look over at my signal generator, it's at 17.492. So there we are. So I can see the output. Now the question is, can I use this method to trace that signal through the radio? That's a good question. I'm going to just change my video a little bit here. Hold on tight. Okay, so now you can see the SDR display, and you can see what's going on in my shop here at the same time. So the clip lead is this green wire, which you cannot see. I wonder if I should flip that to the end. No, I'm going to leave it the way it is. I can do this clever move here. Yes. So this green wire is carrying the signal that the SDR is looking at. And right now it's clipped really to nothing. It was clipped to the insulation of the signal generator lead. So now I'm going to clip this. First I'm going to turn down the signal generator here because it's blasting away. So I don't want to blast my SDR out of the water. So I'm going to hook this right to the output of the signal generator. And what happened? So it's picked up some more noise and stuff. Oddly enough, it's not showing. You probably one of those lines is from the signal generator, but you can't spot it. Let's just see if I can clean this up a wee bit. 1 second here. I'm just gonna stick a ground lead on here. Oh, this is so difficult. Son of a gun. It's tricky business here. Let's experiment, see if it makes any difference first. A little wee bit. Not enough to worry about. Okay, end of that experiment. Now, let's see if we can get the signal generator visible on the screen there. So I'm going to vary it, and we should see one of the lines wiggle. Anything wiggling? I don't see anything. Let's go up a notch. Okay, so there now, there's no question of where it is. Okay, good. We have a strong signal. You can easily see where I've tuned it. So we're going to tune it to right around 17.5, just so we know where it is. Oh, 17.5 is over here. There we are. Right around 17.5. You can see how close it is on this guy too. Good. Now we want to tune the radio to this, but we can't because it doesn't tune. So there is a tricky way of doing this. How can I tune this radio precisely with no dial? There is a way, and the SDR is going to help. We're going to monitor the frequency of the local oscillator in the radio. So the local oscillator, I haven't explained this yet, the local oscillator is like a little transmitter built into the radio, and it produces one signal. And when you tune the radio, this is the signal you're actually changing. The radio is actually an oscillator, and you're adjusting the oscillating frequency. That frequency is mixed, I won't go into explaining how, mixed with the one you're trying to receive. And it so happens that, thanks to some brilliant mathematicians and the way the world works, when you mix two frequencies together, you get 4 coming out. You get the 2 originals, you get the difference, that's the part in between here, and you get the sum of the 2 of them. So that fact is what enables a radio to work. I won't go any further into it right now, but suffice it to say, the main thing you're doing, or the one thing you're doing when you tune a radio like this, is you're changing an oscillator frequency. You're not actually tuning anything in the radio. That's not true. that's not true, because the tuning shaft is hooked up to more than one thing. The tuning shaft is tuning, remember, it's got a 3-section capacitor on it. One section is for the oscillator. Well, the other 2 sections are tuning these guys. So all 3 of these things are kind of traveling together. Okay, did I confuse everybody? I don't think I got confused, so we'll keep going. So how are we going to get the oscillator onto the screen so we can see what frequency it is? So I'm going to disconnect this is the antenna line going to the SDR. You can see I must have shorted it there for a moment. Done something to it. Well, the SDR is a radio with its own problems. This isn't a wonderful radio. Software-defined radios have a lot of problems with them. Perhaps they're not built, or some of them. This is a cheap one. Okay, I had a cheap one, so it's got a lot of problems. So I'm going to put a coil on here. So this somewhat fancy-looking thing is not fancy at all. It's just a coil of wire out here, just hooked up to the phono plug. It's just a coil. You could just take a bunch of wire and coil it up in your hand, and do it that way. But I happen to have this, so it's kind of neat. So is it reacting? Little wee bit. Now I'm going to put this near the oscillator coil that I believe is the one we're interested in, and we are tuned currently to 17,500. So the oscillator is actually running around 18 kilohertz, 455 hertz above. 18 kilohertz is on the right side of the scale. Can we find it? Definitely something showing up there, and it's right in the right spot. I don't understand why it's jumping all over the place. Why is that? So it could be I'm just affecting this coil tremendously, and it's okay. Hold still. Wrong thing, Jim. Wrong thing. Come on, tune the right thing. Oh yeah, so now you can see that thing going back and forth. You see something showing in from the left side? Almost certainly that's just a weirdness in the SDR radio. Well, this is somewhat of a failure here, I think. So a local oscillator there. So let's go to a band that is working. So this is the AM radio band. I didn't really look at the SDR while I was doing that. The output of it was just going all over the place. So the broadcast band, just to be sure again, should be this coil here. Lots of stuff jumped up, but you know, we're at 18 megahertz on that SDR. So this is a bit of an experiment for me. I didn't really explain that, but using the SDR this way is kind of an experimental thing I keep trying out. So we'll go down to the AM radio range. Let's see what I'm doing here. So the coil's picking up stuff. Let's see if we can find this. So now towards the right side of the screen, you can see a white line that's quite high moving. Way out on the right. Let's get this right there. Just make sure. Got you looking at the right thing here. It's right here. line is? Watch now. Yeah, right where the red line is. So that's the local oscillator. That's what I thought we were going to see in that other test. I mean, there's no question that's a local oscillator. What we're going to do now is we're going to use this technique to tune this radio to a particular station, 640, where I know there's a receiver, a transmitter rather. So 640, we want the local oscillator 455 kilohertz above 640. What's that, 1090? 1095? 640, 55, 695, 10. So we wanted a 1095. So I'm going to tune this now to 1095. So I know the local oscillator. Oops, going the wrong way here. Is it going to get there? It's getting bigger and bigger. We're coming in towards 1095 here. $1,095. Let's see how close that is. I'll put the red line on 1095. So the red line is at 1095, and the oscillator frequency is right on it, or very, very close. So I believe if we listen to this radio now, we would hear the radio station 640. So I'm going to switch to the loop antenna as soon as I can find the lead. There's some patience here. What's all this scrambling and sound going on here? I've got to lock down this cable. That's what's going on here. Can't have it tugging on the radio. Okay, now. Round.
Yeah, screen energy. There's no carbon emissions at all. Yeah, so
That's awesome. You know, send me some info.
Tune a little bit.
It's called Green NH3.
Green NH3.
So it's just off by a
I'll
wee
look
bit.
it up and see what it yields.
Yeah, no, because this is, I think, would be perfect. I think it would hurt the government because you don't pay any gas, you won't pay any gasoline tax. So I don't think the government really.
So what that was all about is me trying to spot the local oscillator by picking up a signal from the oscillator coil and having it displayed on the SDR radio. So on the AM band here, the local oscillator is easily strong enough to be spotted and picked up with this coil. And there it is. Just below 1100, right on, I'm sure, 1095. So as long as the IF frequency is 455 exactly, then this will all work out. Well, why this guy's jumping around, I don't know. So we're left with the impression now that there is no local oscillator on the shortwave band, and perhaps on that other band. Without the local oscillator, no frequencies get converted, nothing goes through the rest of the radio, and the radio is silent. It doesn't matter how much tuning you do. So local oscillator can be dead because it won't oscillate at these higher frequencies. We're switching in components as we switch bands. Maybe one of those components is bad. Could be a resistor or something I haven't paid attention to, or some small mica capacitor could be doing this. Oh, why did that all disappear on the SDR? You know what? I think my connection up here is crappy. So where do we go from here? Absolute proof that there's no local oscillator is really what we need. Absolute proof. Okay, that's what we're going to work on. Okay, let's try this. I know the radio is tuned to 640. If we look down here at the dial, we know the pointer, if it were here, would be about like this. We know it's pointing down here to about between 6.5 and 7 megahertz on the high frequency shortwave band. So we know where the radio is tuned. It's tuned around 6.5 to 7 megahertz. So why don't we see if we can make some use of that. I'll simply change bands to this band. Okay, so we go through one on the way, and then that's the end of the run. Yep. So conceivably the local oscillator is now operating at around 6.5 to 7 plus 455. So that means it's around 7 to 7.5. So we'll look on the SDR and see if we can find it. Again, double checking this to make sure. Shortwave. Long way. So I think the shortwave is this one, this upper set again. That's twice I've concluded on. We'll get the SDR now set to the right range, right around 7 to 7.5 megahertz. So 7 is here. That's a ham radio band and then a shortwave band, and they overlap, oddly enough. So what I'll do is I'll bring up the SDR antenna pickup coil here. We'll stick it up near this coil. Well, you can see clearly there is a huge local oscillator, even with the coil this far away from the radio. It's picking it up there at just above 7.3. How sure am I that that is really the radio? Pretty darn sure. Look at all that stuff in there. Now some of that other stuff, the SDR may be creating those things, those weird sidebands and stuff. To be absolutely sure, all I got to do is tune this radio a bit and see that that frequency wanders. Yeah. Just the tall one. Ignore all the funny, fancy stuff. That's just SDR radio craziness, which has been a real challenge in trying to do this. And odd to me that they all stack up on top of each other right there. I don't know. I don't think it means anything. So we have now, let's get this really right. The local oscillator is set to 7.3. You know, I'm going to set it to 7455 because arithmetic becomes real easy at that point. 7455 is going to be right around here. Now the SDR has a delay because it's a computer churning through the data. Just like our brains, it's delayed in analyzing inputs. So I'm going to just verify that we are at 7450. Can't get much closer than that. What that means now is the radio is tuned for 7 megahertz. That's what that means. Put on my headphones here. Again, gotta keep these on while I'm doing this. So I'm now going to fire in a 7 megahertz powerful signal and see if the radio picks it up. Clearly the local oscillator is not the bad guy in this deal. 7. Seven at a fairly high level. It should come in right on 7. Let's give it a full blasty. Nothing. Okay, think for a minute. What antenna you got hooked up, Jim? Okay, so hold on. False test. We're hooked up to the loop antenna. False test. Let's put the signal generator there. Try this again. Okay. Here we go. Okay, signal generator right on the antenna. Let's turn this down. Let's see if we can hear it. volume is up. Volumes are up. Oh! And we couldn't hear it because I didn't have the volume turned up. The hum is fooling me. Okay, now we're listening to it for the first time. There it is. Oh, 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 oh. I have to really work my way through all my mistakes and errors. Good. Excellent. Let's see if we can beat this guy up. Go back to these two coils. Is this for sure? Is this for sure the right spot? Yeah. 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 Definitely. A little bit. Now we're doing this in the wrong place on the band. I think we're doing it in the middle. That's okay, this is all preliminary stuff. We're just finding out. No reason to touch those two. Well, they didn't give us too much of a boost, but it's definitely working. It's there. Now we have a fairly strong signal. Let me just double check all this. Yeah, definitely. We have quite a strong signal fed into this radio, and it seems like its response is very, very weak. That's the impression I've got. Weak in the high end of this band. Not even at the high end, we're at 7. We're at the low end. Okay, well let's try exactly the same thing now with the long wave band. Because maybe it's there. It just needs one heck of a signal. Again, long wave, not terribly important these days. So the long wave band is the other extreme band setting position here. Oh, that hurt my ears. Hurt your ears. Okay, so we're on a long wave. Volume's back up. I forgot about that. We know where we're tuned because I haven't changed the radio very much. So we're back to 640. So we're wow, 150. You know, I just may never have turned my signal generator that low. That's why we might not have ever heard it. 150. 150. I can almost sing that high. Yeah, stick my finger in an outlet, I'm liable to reach 100 kilohertz. So 150. 150. Way down here. Okay. I didn't hear anything. Juice it up. All the way. Let's hit them hard. Make them cry. No, not happening. Okay, so we'll do the local oscillator search. Search for the local oscillator. So if the radio's tuned to 150, yeah, see, I don't understand how this operates with a local oscillator on this low band. That's a really good question. I don't know how this radio works on this low band. I don't think you can mix in a local oscillator at 455. Don't know. It still has a local oscillator adjustments. Local oscillator. Okay, let's look at the SDR here. Way down there. You can still get a difference frequency between 152 and 455. get a difference frequency between the local oscillator and 152. That comes out to 455. If the local oscillator were to be 600 hertz at this point. 600 hertz. It's this one down here. Look at that. There it is. 675. For sure. That's tuned. What happened to it? There it goes. So I was doing the fine tuning. You couldn't see the movement in it. You see it moving back and forth. Now there's just nothing down here that we can pick up. But what I'll do is we'll set this to, again, some nice round number. Where are we here? We're at 6. Can I set it to 4? Can I get it to, let's go 6. Oh, this is, I don't know what to think here. I don't know. Set it to 700. I shouldn't have moved that. I should have left it. Okay, so it's at 700. So that's going to be roughly around this 150, 175. So 700 minus 455. 245. 245. This radio's tuned to 245 kilohertz. Is it? Is it really? 245 kilohertz. Let's find out. We can pick anything up. Everybody's turned up and listening. Well, I didn't hear a thing. 245. That doesn't add up, does it? 245 plus okay, you just don't have enough brain cells left to do something like that. So the local oscillator was at what? Okay, let's just redo this properly. 700. 700. Come on, calculator. Show it the light. 700. And we subtract 455. No, we don't. Let's try again. 700 minus 455. We got a dirty 4 button. 245. 245. 245. I don't hear a thing. Signal's up high. We can boost it even more this way. Okay. So this signal now, I can't get any more out of that. And I sure don't hear anything. Guess what? It's right there. Giving it the works. It's there. It's just phenomenally weak. Well, maybe it's a tuning. That's what I'm here for. Let's try it out. Now, the problem with this, that's a big problem. Okay, So the thing I need to adjust is way back in there. They've put holes in the cans here so you can slide a screwdriver through. I need to put my hand down in this area to do it. Oh, and then this is blocking the, oh my gosh, how are you going to do this? Just like this. Ready? There we go. Got quieter. There's just nothing there. It's just not enough. Okay, we'll try this one. I mean, these can't be so far out. I don't think. Way quieter. Watch your hand, Jim. Extremely weak. And yet the band just above the AM band seems normal. Okay. It's all working but weak on two bands. I think that's the conclusion I can get right at this point. I think that's the end of today. That's the conclusion. You know what we're gonna do right now? I'm gonna find out how hot those resistors are. That's just my parting deal here. So just by the way, this came to me from Banggood. Banggood is a Chinese supplier, a little like Amazon or stuff like that. Okay, so we're set to 80 up here. I'm going to reduce that. So anything close to 55 should start appearing red. Make sure I get this on camera for you decently. Blew this once before. So there you can see the resistors down here. They're just a little bit warm. There's nothing going on there to be concerned about. Come up through here. Okay, so that resistor is running at 62 degrees. That's this red one right here. 62 degrees. This one is running at 60, almost 70. This guy's cool as always, and this guy's hot too. He's running up around 90. So when I look at them, you know, what caught my attention is it looks like the paint is melting on here again, and the same thing here. I think these resistors are still running too hot. But it could be because of the operating situation here on my bench. If it was properly loaded with tubes and everything else, I'm going to calm those down. We'll find out in the long run. It's not dangerously hot at this point though. Okay, so thanks a lot for watching, and I'm on my way. See you tomorrow.